The average profit of movies from 1970 to 2013. This project took data from a CSV file called Movies and calculated the average profit that the movies made each year. The data provided the budget of each movie as well as its domestic and international revenue data from 2013. We wanted to analyze the rate at which movies made profit throughout the years from 1970 until 2013, and we plot a bar chart to compare the years. The reason we chose to calculate the average profit of movies over the years was to try and show how the success rate of movies has changed. This was fascinating to us as we were both passionate about television and movies, and we also believed that it would be interesting to see how much some of our favorite movies had made, as well as answering the question to if movies are making more profit now or before.
Applying what we had learned. While designing the code, there were multiple strategies that we had learned while being taught how to design programs systematically that we had to apply. First of all, the concept of helper functions was used widely. It would have been impossible to make a graph without using a number of helper functions and using reference rule to embed these into other functions. With so many functions, it was also clear that we needed to refer to the how to design a function method in order to design things in a proper order and accomplish our goals. The most beneficial aspect was when we created tests for the functions, as it allowed us to challenge the functions in various scenarios to provide the accurate results we intended.
Design issues and challenges. The main design issue was due to the fact that there was an outlier in the data. Certain years from 1970 to 1980 only had a few movies in them, especially 1975 compared to 2013, which had close to 100 movies. This caused our graph to have a skewed scale, where the data from more recent years was so insignificant that it was impossible to read. To fix this, we chose to make a second chart that would only map the data from 2000 onwards.
These are two graphs shown below. The first is of the entire data set, and the second is a graph where the code has been modified so only the years after 2000 are shown.
In the first graph, we can see the average profit from 1970 to 2013. This graph shows that from 1970, there was a decrease in the average profit as the years went on. However, this graph isn't very accurate because in 1973, we can see that there's a big outlier that shifted the graph way above and doesn't allow us to see the rest of the graph properly. However, in our second graph, when we got rid of a lot of the outliers and only graphed from 2000 to 2013, we saw that there was a very random assorted list of data for the average profit. Therefore, we can't make any assumptions that as the years went on, there was an increase or a decrease in the average profit made.
We were able to solve our problem of seeing if the average profit of movies had increased in profit throughout the years by using multiple helper functions to calculate the profit of each movie and divide by the number of movies in its year and plot this in the bar graphs shown below. The most difficult part of coding the program was finding the number of movies that were from each year, which was needed in order to calculate the average. Creating the various helper functions became a hard task as they each needed to have a good flow in the program, as well as being able to calculate correct results no matter the situation. For example, if there was not applicable data.
There are several issues in the movie industry that systematic programming skills that we have learned could help solve. For example, if we use these skills of making helper functions for intended tasks, like calculating data for given spreadsheets, we could help movie industries with making graphs of the rate of viewership depending on the country watching, or providing calculation help with the rate of growth in their income if they spend more on a budget by using data from past movies, or even designing functions that can read the data set of movies' income per day and predict the growth of it.